Good afternoon, geometry class. I hope that you are doing fantastic. We are going to be doing section 9.6, solving right triangles today. So all you need to have is a piece of paper and a pencil, and you should be ready to go. We've been talking in chapter 9 about right triangles, about Pythagorean theorem, and also about trig ratios. Today we're going to talk about something called inverse trig ratios. So we're still going to be looking at a right triangle, and we can still label those sides A, the angles A, B, and C. Let's, for instance, go ahead and label the sides X, two of the sides X and Y here. Now, if I wanted to talk about angle A on this triangle, and I was talking about the sine of angle A, it would mean opposite over hypotenuse, or X over Y. But let's say, for example, that I didn't know what angle A was, and I did know what X and Y were. So before I knew the angle and I was trying to find a missing side, we're going to talk about something called inverses today, which is what we use when we have the sides but we don't have the angle. So if we wanted to find the measure of angle A itself, it would be sine inverse of X over Y. So let's say, for example, that this is a 3, 4, 5 right triangle, and I know the sides, but I just don't know the angle. So I could plug in the values here. Sine inverse of, this would be 4 over 5. And basically what we're doing is we're asking your calculator to tell you what is the angle that has a sine of 4 over 5. Now, the way that you're going to do that on your calculator is first by pushing the second button, and then sine. And you're going to see on your screen there's a sign with a little -1 next to it. In parentheses, you put 4 divided by 5, end your parentheses and put enter. And your calculator will tell you that the angle that has a sine of 4 over 5 is 53.1 degrees. Now we can use any trig ratio that we want to find a missing angle. We can use sine, cosine, or tangent. So let's say we wanted to use inverse cosine to find the angle B. Interestingly enough, let's take a look at this for a second. Let's do cosine of B. Cosine is going to be adjacent over hypotenuse, which would still be X over Y. So if I wanted to find what angle B was, I can say, okay, cosine inverse of X over Y, or cosine inverse of 4 over 5. If I do that on my calculator, I'm going to push the second button and then cosine 4 divided by 5 in the parentheses and push enter, and I get 36.9. So that would tell me that angle B was 36.9. Now I didn't really need to use an inverse trig ratio to do that because I could just take 90 minus 53.1 and get 36.9 that way. It's also possible to do a tangent inverse. So we can use the same procedure for doing tangent inverse. Let's go ahead and skip to a specific example. So I think that I would like to go ahead and look at example number 1 here, where we're being asked to solve the right triangle. So in this particular case, solve always means that I want to find all of the missing information. In this particular case, I don't have either of the angles, but I do have 2 of the 3 sides. So I need to find everything that's missing. So let's label these angles A, B, and C. So you can actually pick either one that you would like to first, but let's go ahead and find angle A first. We can see that with angle A, we have an adjacent and a hypotenuse, so I know I want to be working with cosine. Cosine of A is 4 over 17. That means that A is going to be the cosine inverse of 4 over 17. Keeping in mind that we use inverse when we're trying to find a missing angle. So in this case, because we have the sides, but we don't have the angle, that's why we're using the inverse button. Then when we plug that into our calculator, we're going to get that A is 76.4. Now, like I said, I wouldn't do another trig ratio at this point To get B, I would just take 90 minus 76.4 and get 13.6. And the only other thing that would be missing, let's fill in what we have so far. B would be 13.6, A would be 76.4. The only other thing missing from this triangle would be, let's call that side little a, would be that missing side there. We can do Pythag for that. So we would say a squared plus 4 squared equals 17 squared, or a squared plus 16 is equal to 289. We would subtract 16 from both sides and get a squared is equal to 273. Take the square root of both sides. If we want to put this in decimal form, it would be about 16.5. There are actually no pairs there. So if you wanted to leave it in radical form, it would just be square root of 273. Okay, let's go ahead and figure out another problem. So let's do example number 2. Keeping in mind that we use the inverse button when we're trying to find a missing angle. So example number 2, we also have a right triangle. Let's go ahead and use sides of 5 and 12 here. And then we'll label this as angle A, B, and C. So let's go ahead and find A. Now, if I look at A, I can see I have an opposite and an adjacent. So I want to say that the tangent of A is 12 over 5. And if I'm trying to find the actual angle, I know I have to use the inverse button. So I would say the tangent inverse of 12 over 5 would give me the actual angle. So I'm going to, on my calculator, hit second tangent, and then in parentheses, put 12 divided by 5, end my parentheses, and I'm going to get that A is 67.4. To find B, I would take 90 minus 67.4 and get 22.6. And then to find the third side, I can use Pythag. Does anybody remember what the third side of a right triangle is with legs of 5 and 12? It's a very common right triangle that comes up a lot during the school year. Hopefully you've kind of started to memorize these. This is going to be a 5, 12, 13, which is the second most common right triangle out there. Okay, let's go ahead and do example number 3. So in this example, what we're being asked to do is to find which of the two acute angles has the given trigonometric ratio. So let's go ahead and write example 3 here. And then let's go ahead and use a 5, 12, 13 again. And the question is saying the sine of the angle is 12 over 13. So the question is, which of the two acute angles, that would be angle A or angle B, has the given trigonometric ratio? Which angle has a sine of 12 over 13? That would be angle A. Angle A has opposite over hypotenuse of 12 over 13. Okay, let's call this, I don't know, part A, I guess. All right, now for part B, the question is, the cosine of this angle is 5 over 13. So which angle has a cosine of 5 over 13? Keeping in mind that cosine means adjacent over hypotenuse, this would again be angle A. Okay, and then for the third part of example number 3, they want to know the angle that has a tangent of 5 over 12. What angle has a tangent of 5 over 12? Well, tangent means opposite over adjacent, so that would have to be angle B. Angle B would have a tangent of 5 over 12. Now, let's go ahead and do this problem without a picture. So we're gonna do the same problem that we have been doing. Example 4, the question is, if the sine of A is 0.78, what is angle A? So sometimes you're just gonna get this as a decimal, not as a fraction, but we do the same work. We would say A would be the sine inverse of 0.78. You're basically asking your calculator, hey calculator, what angle has a sine of 0.78? And your calculator, if you punch that information in, will tell you that that angle is 51.3 degrees. Okay, let's do one last example. We'll call this example number 5. It's a short word problem. So example 5, it says, find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. So let's draw this telephone pole here, and let's put the sun up here. It says the pole is 12.5 meters tall. The shadow it casts is 18 meters. And they want to know the angle of elevation. Now remember, the angle of elevation means from a horizontal line going up. So we're gonna call that X. So we can see here we have an angle, an opposite, and an adjacent. So I'm gonna write the tangent of X is 12.5 over 18, or that angle X is gonna be the tangent inverse of 12.5 over 18. When I punch that into my calculator, the calculator is going to tell me that the angle I'm looking for is 34.8. All right, guys, you're done with notes for chapter 9. Good job. Bye.